For this question, we are talking about problem type 3 about permutations and combinations. And now we're sort of getting to the really hard ones. And they give you one question, and your real main objective is to sort out whether it's a permutation or combination scenario and then decide how to handle it. I'm going to show you actually one of each type. This first one says a committee consisting of 2 faculty members and 3 students is to be formed. Every committee position has the same duties and voting rights. There are 7 faculty members and 11 students eligible to serve on the committee. So in how many ways can the committee be formed? So first of all, you need to think about this for a second and decide, does the order matter? And if you think about putting, several people on a committee, so if you talk about 2 faculty members, one faculty member and the other being 2 faculty members being on the committee, if you reverse the order, they're still on the committee. It doesn't change anything. So this is a situation where the order doesn't matter. So when order doesn't matter, remember that is a combination. And same thing with the 3 students. So the order that they're on there makes no difference. So we're dealing with a combination. The tricky thing is we're selecting 2 faculty members out of 7, and we're selecting 3 students out of 11. So we're going to have 7C2. So selecting 2 faculty members from the 7. We need to figure that out. And we're going to have 11C3, so selecting 3 students from that group of 11 students. So we'll figure that out. So let's go do that just quickly. Clear that off, and we'll go to math, over to probability, option 3. And we wanted 7C2, and figure that out, and we'll do it again. And whoops, try that one more time. There we go, option 3. We wanted 11C3, so that's selecting 3 students from that group of 11. So there were 21 ways to select the 2 faculty, and there are 165 ways to select the 3 students. So that was 21 ways there and 165 ways there. And if there are 21 ways to do one thing and 165 ways to do something else, then it's the product, 21 times 165. And I'll just go back to my calculator and multiply that 165 times 21 and say there are 3,465 ways. So that's 3,465 ways to put the committee together. So how many ways can the committee be formed? There's your answer. So that one, you had 2 different scenarios, and they're both combinations. And now let's look at another one. I'll scroll through the ALEKS explanation, but that's pretty straightforward. Fundamental counting principle is why we're multiplying those together, by the way. If E1 can occur in M1 ways and E2 can occur in M2 ways, then the number of ways E1 followed by E2 can occur is you multiply them together, and that's what we did. And you saw there's the 21 and 165. So that's that one. The other scenario here, I just said version 2 of this problem type 3. We've got a serial number for a product to be made using 2 letters followed by 3 digits. So the letters be taken from the first 6 letters of the alphabet with no repeats. So again, that's reminding us that it's without replacement. The digits are taken from the 10 digits 0 through 9 with no repeats. So how many serial numbers can be generated? So again, that's no repeats. If repeats were allowed, then it's a different question. So this reminds us that it's without replacement. So that tells us it's either going to be a permutation or a combination. And the fact that the order makes a difference. So in other words, if I start making a serial number out of 2 letters, and we're only using the first 6 letters of the alphabet, so A, B, C, D, E, and F. If my serial number starts with AB, and then I could have it start with BA, that's using the same 2 letters but in a different order, so the order definitely matters here, and so that's going to be a permutation. So to find those 2 letters, I'm going to say 6P2, so that's a permutation of taking 2 letters from those first 6 letters. And then I'm going to take 3 digits from the 10 digits 0 through 9. So that's 10P3. So I need to figure out those 2 things separately. Then we'll multiply them together, and we'll have our final answer. So let's go calculate those 2 permutations. And so I'll say that was 6P2, and the other one was 10P3. So I'll do that again. That was 10. Didn't move that down enough. 10P3. And so 720 times 30, so I'll take that now just so I have that done. So there's 30, there's 720, and then there's 21,600. So 30 of them here, 720 of them here. So if I take 30 times 720, that was 21,600. I may be wrong on that one. Oh yeah. 21,600. Yep. So 21,600 serial numbers could be constructed using that process.